All right, you can extend the concept of a square root, this section 5.1. You can extend the concept of a square root to other types of roots. For example, 2 is a cubed root of 8 because 2 cubed is equal to 8. In general, for any integer n greater than 1, if b raised to the nth power is equal to a, then b is the nth root of a. And nth root of a is written as the nth root of a, where n is the index of the radical. Remember, when it's a square root, we just don't put anything there because it's understood. So the real nth roots of a, so let n be an integer, where n has to be greater than 1, and let a be a real number. So if n is an even integer, if a is less than 0, it has no real nth roots. Again, it might have imaginary ones. If a is equal to 0, you can have one real nth root. So the nth root of 0 is equal to 0. And if a is greater than 0, you'll have two nth roots plus or minus the nth root of a, which we could write also as an exponent as equals plus or minus a raised to the 1 over n power. If it's an odd integer, if it's less than 0, you're going to have one real nth root. So nth into the a to the nth root of n is equal to a to the exponent 1 over n. If a is equal to 0, you're going to have one real nth root. Again, the nth root of 0 equals 0. And if a is greater than 0, you'll have one real nth root. The nth root of a, again, is equal to a over 1 to the nth power. So example 1, find the indicated real nth roots of a. So on the first one, we have n is equal to 5. Well, if n is equal to 5, you know that is odd, right? And if it's a is negative 243, so we know that that is less than 0. So we know that we should have, according to our diagram here, we should have one real root. All right, so what that tells us is that the fifth root of negative 243 is going to equal negative 3. So they also say you can write it in exponential form, or we could write it as negative 243. Notice it's in parentheses. The 1/5 would be on the outside. Again, if you plug that into your calculator, either way, you should get negative 3. All right. For B, we have n is equal to 8. So that tells us it's even. A is equal to 256. So that would make it greater than 0. And again, if we look at this one over here, because that's what it's talking about, we can see that we should have 2 real nth roots. So we're going to have 2 real nth roots. So again, notice how here it did put the plus or minus there for us. So we're going to say the same thing, plus or minus the 8th root of 256, which will equal plus or minus 2. Again, you can plug it in your calculator that way, or you can plug it in your calculator as 256. Notice it's in parentheses. I'm going to put the 1/8 on the outside. And again, that would equal plus or minus 2. We'll try it both ways and you can see. So a rational exponent does not have to be of the form 1 over n, which is what we just used there. Other rational numbers, such as 3 halves and -1/2, can also be used as exponents. Two properties of rational exponents are shown. So let a raised to the 1 over n power be an nth root of a, and let m be a positive integer. Then we can write it as a is equal to m divided by n, and we can rewrite that as a to the 1n. We could put the 1n in the inside and the m on the outside. Again, a power raised to a power. Or you could take the nth root as this and again raise it to that power. Okay, and for a negative exponent there, remember it's going to be 1 over. That was something we learned in Algebra 2. And again, same thing. I can take what I have here, it's right there, or I can use this one right here and do that one right there. What you should find out, ladies and gentlemen, is that one of them will work. Sometimes you can use either one, but sometimes it's easier to see one than the other. All right, so we're going to evaluate each expression in exercise 2, example 2. And let's see, the first one is 64 raised to the 4/3 power. So I'm going to do it both ways for you. I'm going to do it with the rational exponent form, or I'm going to use the radical form, which again is using the radical symbol. So if I use the rational exponent form, so that's telling me I have 64, and I'm raising it to the 4/3 power. All right, so it said I'm going to take that 64, and I'm going to take the 1/3 power of it, and then I'm going to raise that to the 4th power. Well, the 64 raised to the 1/3 power, is going to be 4. So 4 raised to the 4th power is equal to 256. Okay. If I use radical form, and again, it's going to choose on which one you like better. So if I take 64 raised to the 4/3 power, I can write that as the cubed root of 64. And again, just think, what number times itself equals 64? That's what it's saying. And again, that would be 4. And we're going to raise that to the 4th power. So either way, you'll get 256. For part B, we're going to take 16 raised to the -5/4 power. So let's go ahead and do the rational exponent form first. And if I use that, I'm going to have 16 raised to the -5/4. All right, which is equal to, again, I'm just going to choose to do 16 raised to the 1/4. Notice how I left the negative on the outside there. All right, when I do that, well, the 4th root of 16 is 2. So now I have 2 raised to the -5th power, which now I have that negative. Remember, I should bring it down like that, and I'll get 1/32. If I do the radical form, I'll have 16 to, I'll start with what I started with, 16 to the negative 5/4. Again, that's the fourth root of 16 raised to the negative fifth power. Notice how each time I get the same answer, which again, 2 to the negative fifth, I can write as 1 over 2 raised to the fifth power, which is 1 over 32. So again, same answers here and same answers here. So choose the one that you like better, okay? And tell me to get my face out of the way. All right, when using a calculator to approximate an nth root, you may want to rewrite the nth root in rational exponent form, okay? So example 3, evaluate each expression using a calculator. Round your answers to 2 decimal places. Okay, so it depends on what calculator you use. All right, I find that sometimes, again, you might have to do this. So I'll have 9. And remember, the caret is what would raise it to something. All right, on some calculators, when you do that, it will put it up there and then you can just put it as a fraction form. Other times, with other calculators, you're going to have to put it in parentheses. All right, and maybe we can practice that. So to the 2 decimal places, if I plug that into my calculator, I get 1.55. All right, so by the same token on B there, I'm going to put 12. Again, I'm going to use my caret symbol. And again, it depends on the calculator, ladies and gentlemen, because sometimes the calculator would do something like raise it to the third power and then divide it by 8. So again, sometimes it just makes more sense to put it in parentheses. And on that one, you'll get 2.54. And what it says here is on this one here, again, I told you it might be easier to write it in rational exponential form. There's my 4. This one will go on the top always. That one goes on the bottom. So we can say we're going to have 7 raised to the 3/4 power. And let me get approximately 4.30. Okay? So, like I said, the thing might be to use, here, why don't I write that down? So, use parentheses to enclose a rational exponent. And finally, the last, to solve an equation of the form u raised to the nth power, where again, n can be any integer, all right, is equal to d, where u is an algebraic expression, take the nth root of each side. So for example 4, find the real solutions of the first one, a, 5 times x raised to the third power is equal to 320. So again, we're going to still do the same thing as we always do. When we're undoing, we have to do the division first. So we're going to divide by 5. So if I divide by 5, I'll get that x cubed is equal to 320 divided by 5 is 64. So we have, how do I undo a cube? I take the cubed root. And when I do that, I'm going to have the cube root of x cubed is equal to the cubed root of 64. So I want you to kind of think, like I've said before, a square and a square root kind of cancel each other. So the same thing here, a cubed and a cubed root cancel each other. What are you left with on that side? You're left with x. And again, just earlier, I showed you that the cubed root of 64 was 4. Okay. And remember, that's because we had a multiplication on the one side. On this one here, we have parentheses. So we have to undo the exponent first. So we have a fourth root. So how do I undo that? How do I undo a power of 4? Excuse me, I just told you. You're going to take the fourth root. Or roots. Why do I say or roots? Because remember, since this is even, we know that we're going to have x plus 3. And it's going to be plus or minus the fourth root of 24. Now to get x by itself, what do I need to do? I need to subtract 3. So then I'll have x is equal to 3 plus or minus the fourth root of 24. Okay. And write each solution separately. So I'll have x is equal to, and that should be negative, right? Because I took it over. So I should have negative 3 plus the fourth root of 24. And I'll have x is equal to negative 3 minus the fourth root of 24. If it tells you to leave it in radical form, you're going to have to do that. But I didn't tell you on this one here. So I would just plug it into your calculator. And I'll get that x is approximately equal to negative 79 thousandths, or x is equal to approximately negative 5 and 21 thousandths. And that's it.